Okay, so this is what's known as set builder notation. Okay, but what we really want to do is we want to construct a union of both sets. Now, to construct a union of both sets, what we need to do is we need to know what the elements look like that are in this particular set X. Now, they're clearly defined here, but it's a little bit more complicated in the sense that it's defined based on this condition here. So let's actually list X in roster notation. Yeah. So X in roster notation are the set of observations. Okay. They have to be integers, and the integers need to be greater than or equal to -2. So that would be -2, -1, 0, 1, 2, 3, and they need to be less than or equal to 4. So 4 is in the set X. What about the set Y? Well, the set Y is a set. The members or elements are integers, okay, and they need to be greater than or equal to 6. So they need to start with 6, 7, and they need to be less than or equal to 8. So Y actually looks something like this. So X union with Y, okay, is a new set. The set contains all the members of X, so we take everything out of X and we throw them into this set. So we have -2, -1, 0, 1, 2, 3, and 4. And we also take everything that's in Y and we throw it into this set. So what we end up with is 6, 7, 8. Okay, so we can actually see that X union with Y is the set that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 members. Okay. Is there another way we could actually write this? We could write this in set builder notation. Okay. But let's think about the values that are in here. Okay. Well, all the values are integers. Okay. They're greater than or equal to -2. Okay. They're less than or equal to 8. And the only integer that's missing is the integer 5. Okay, so we can actually write this in set builder notation using a number of conditions. So let's do this. So we have X union with Y is going to be the set of observations or members such that the members have to be integers. Okay, and these integers need to be greater than or equal to -2. So -2. Okay, the members need to be greater than or equal to -2, and they need to be less than or equal to 8. Okay, but also another condition is that we don't put in the integer that's equal to 5. Okay, so we'll say that X cannot be equal to 5. Okay, so there's how we've written. Now what we've done is we've written X union Y in roster notation, but we've also written X union Y in what's known as set builder notation. Okay, so there's two examples of how the union operator works. And what about the intersection operator? So let's have a look at the intersection operator. Let's try to define the intersection operator. Okay, so the intersection operator. So let's write that down. Intersection. The intersection operator. Definition. Okay, let's provide a definition for this particular operator. Okay. So let's just say once again, if I want to find the intersection of two sets, I need to have the two sets in my hand before I can actually find their intersection. So what I'm going to say is given two sets, X and Y, okay, we define the intersection, okay, of X with Y, okay, symbolized or denoted by X like an N, X intersected with Y, okay, to be the set, okay, X intersected with Y is a new set that contains members, and the condition associated with the members is that the members must be elements of X and the members must be elements of Y. Okay, so this is our definition. So what it's really saying here is this, is that if you want to be part of the intersection of two sets, okay, well, first of all, you need to be given two sets first initially. If you want to form their intersection denoted by X intersection Y, well, then to be in the set X intersected with Y, okay, these members, these X's, okay, have to be in the set X and they have to be in the set Y. So they need to meet both conditions. So let's have a look at an example. So here's our example. Okay, so here's a quick example. So let's say X is the set that contains the values 2, 4, 6, and 8, and let's say y is the set that contains the values, let's say 4, 6, 8 and 10. Okay, and if I want to find the intersection of the two sets, well, x intersection with y is equal to, well, x intersection with y is equal to a new set. Okay, the items that are going in the set, well, first thing, they have to be in x. Okay, so here's some candidate objects, because these are the objects that are in x, or these are the members of x here. So to be in this set x intersected with y, you need to be at least in x and you need to be in y. So there's two conditions to meet. So let's take the elements of x first of all, okay, and let's see, do they meet both conditions. So what about 2? Well, 2 is certainly in x because it's listed here. Okay. But is 2 also listed in y? No, it's not. Okay, you can clearly see 2 is not listed in y. Now, to be a member of the intersection, you need to be in both sets. So 2 cannot be in the intersection. What about 4? Well, 4 is certainly a member of x, okay, because it's listed here. Is 4 also a member of y?